Hey guys, so today we're going to be talking about special segments and circles. So our learning target is to calculate the segment lengths in circles number one, the first thing is when chords intersect inside the circle, like this example here. And the second thing we're going to learn about is when secant and tangent lines are present and they intersect outside the circle. So let's do the first part. So do you see how there's two chords? There's this chord right here that I'm tracing, right? And then there's this other chord here. Okay, so there's two chords and they intersect right here. And we're not going to talk about angles this time. We're going to talk about the length of the segment. So when they intersect, this chord is cut into two pieces. This side right here is 2 centimeters. And then this other side over here, I'm going to trace in purple, is 9 centimeters. Okay, and then this other chord, right, the second chord is also intersected. This piece here is 6 centimeters. And then this other piece here is 8 centimeters. So there is a rule, there's a theorem, okay? So the first theorem is going to be that when you have two chords intersecting, right? If two chords intersect inside a circle, the products, so the word product is the answer to a multiplication problem, of the lengths of the chord segments are equal. So this is what you do. The first thing you do is you have to highlight one of them. It doesn't matter which chord you highlight it. I'm picking this chord right here, 2, with pieces 2 and 9. So I highlight one, and then I find the pieces. So this piece is 2 centimeters. So 2 centimeters times the other piece. See, piece times piece. The other piece is 9. So I multiply 2 times 9. 2 times 9 is 18. Well, that's going to equal the other two pieces, the product of the other two pieces. So the other two pieces are 6 and 3. So 6 times 3. So 6 times 3 is 18. So do you see that? So the pieces are going to multiply and they're going to equal each other. 18 is 18. And that's always going to work. Piece times the other piece is going to be the same exact answer as the piece times the other piece of the other chord. But the most important thing is you need to highlight one of the chords. Okay, so let's try this number one. All right, so I have two chords that intersect right here, right inside the circle. So I'm going to pick one to highlight. It doesn't matter which one you highlight. I'm going to go ahead and highlight this one. So I highlight or I ring it, right? So one piece is 8 and the other piece is 9. So I'm going to write 8 times 9. 8 times 9, right? So 8 times 9 is going to be the same thing as 12 times x. So I'm going to write 12 times x. And then we just solve it, 12 times x. So what's 8 times 9? Go ahead and solve that. 12 times x is 12x, right? 8 times 9 is 72. Oh, 12x. I forgot my x. There we go, 12x. Now, how do I solve this? Remember how to solve in algebra? You have to solve for x, so you're multiplying. So you're going to, divide. So divide by x, by 12. 12x divided by 12 is just x. So divide on the other side by 12. What is 72 divided by 12? Good, you should have gotten 6. 72 divided by 12 is 6. So that means that this piece right here is 6 centimeters long. So 6 times 12 is the same thing as 8 times 9. So what's 6 times 12? It should equal 72. Check it. Yeah, I checked it. 6 times 12 is 72. And then 8 times 9 is 72. So piece times piece is exactly the same as the other piece times piece. Go ahead and try number 2. Set it up real quick. First, highlight one chord. Doesn't matter which one, just highlight one. Okay, so I'm going to highlight this one here. And it doesn't matter which one. So I'm highlighting an 8. And my other piece is x. Okay, so I'm going to fill in piece times piece. So x times 8. Do you get that? That's this piece times this piece. So x times 8 is 8x, right? 8x equals the other two pieces multiplied. So 7 times 16. So 7 times 16. So figure out what is 7 times 16. Good. 7 times 16 is 112. So I have 8x equals 112. So how do I solve for x, right? You're going to divide by 8, divide by 8, divide by 8. So what is 112? 112 divided by 8. Good, you should have gotten 14. So x equals 14. So that means that this little piece right here is 14 centimeters. So 14 times 8 must equal 112. Try it. 14 times 8. Good. 14 times 8 is 112, and 16 times 7 is 112. So piece times piece equals other piece times piece. All right, let's try the other two. Okay, here on number 3, we have another set of chords. They intersect right here, so it divides into 2 pieces. So go ahead and shade. I'm going to shade the bottom one. So I'm going to highlight this one, which this is 12, right? 12 and x. So I'm going to put 12 times x equals 15 times 8. Go ahead and try that and solve it on your own. Okay, you should have written 12 times x equals 15 times 8. So 12 and x, 15 and 8. So 12 times x is 12x. And what is 15 times 8? Okay, good. So you had 120. 15 times 8 is 120. The next step is going to be to divide by 12, right? So 120 divided by 12. 12x divided by 12 is just x. So x equals, good, 10. So I'll put my 10 here. So 10 times 12 is 120. 15 times 8 is 120. So they do, the products are congruent. Very good. Try number 4. Okay, you should have written x times 30 equals 20 times 27, or any order. You could put this one first. But x has to be multiplied by 30, and 20 needs to be multiplied by 27. Go ahead and solve that one. Okay, you should have gotten x equals 18. Okay, let's do number 5. Okay, go ahead and try number 5. Let's go ahead and shade it. Right, I'll just shade. It doesn't matter. We can do this one. It doesn't matter which one you do. Okay, so 27 times 20. The shading helps you keep them organized. So I know it's going to be 27 times 20 equals 30 times x. Go ahead and try this one. Okay, 27 times 20 is 540. 30 times x is 30. You do the last step. Good. The last step is to divide by 30 on both sides. So 540 divided by 30 is 18. You should have gotten 18. So 20 times 27 is 540, and 18 times 30 is also 540. That always works. Go ahead and try number 6. Hey guys, you have this exact document as a Google Doc, so you can write on it. It's not a Pear Deck, it's a Google Doc. So you can also write on it. I just can't see it, but you can write on it so you can highlight. Try it. Highlight for yourself. It helps. It helps especially me because I have dyslexia and I'll get these numbers mixed up. So if you highlight it, you know you're going to put 6 times 6 together and then 4 times x together. It's really helpful. Good, you should have gotten 9. So 4 times 9 is 36 and 6 times 6 is 36. So the theorem always works. Answer this question. So when 2 chords intersect inside the circle, what should you do? Explain it out loud to someone. That will help you. Okay, we just learned that if the 2 chords intersect inside the circle, so see how they meet inside? Then you highlight one piece, and then you do the theorem. Piece times piece equals the other 2 pieces multiplied together. Great. Okay, we're going to do part 2. Okay, notice this one. This is part 2. They don't intersect inside. Now they're intersecting outside. So you have a tangent. This one's a tangent because it only hits the circle one time. It doesn't go inside the circle. This line right here is a secant because it hits twice and it goes out. Remember, secant goes outside the circle. So they intersect right here. So this is a little bit more work. So this is going to be the length of the whole segment. So you pick one. So let's pick this side first. What is the length of the whole segment? Well, I don't know because I don't know what this is. So 12 plus x. So the length of the whole segment is 12 plus x. And we don't know exactly what it is because we don't know what x is. But I'm going to put 12 times x, right? So length of the whole thing is 12 plus, right, plus x. 12 plus x. Let me make that look like a plus sign, sorry. 12 plus x is the whole thing. Now the piece sticking out. So let's highlight the piece that's sticking out. So sticking out of the circle. So that's the outside right here. This piece right here. This is outside the circle, right? So this is 12. So I'm going to write times 12. So let's look at that again. It's the whole thing, so which is 12 plus x, right, times the piece sticking out. The piece sticking out is 12. That's how long it is, the one sticking out. All right, now let's look at the other side. The same thing. What is the whole thing? Well, the whole thing is 18. So I'm going to write that here. The whole thing is 18. The length of the whole tangent is 18. And of that 18, how much is sticking out? Well, let's look. How much of it is sticking out? Well, you can clearly see that the whole thing is sticking out, 18. So I'm going to write 18. So 18 times 18, which is 18 squared, right? So what's 18 times 18? And then I do this here. We have to use distributive property. So what's 12 times 12? Good. It's 144. And then 12 times x, right? 12 times x. Yep, very good. It's 12x. So I'm going to put 12x equals, go ahead and see what is 18 times 18. Good. 18 times 18 is 324. So now I need to solve this. So I have 12 times x. They're stuck together. So I do that last. So I have to subtract 144. So I subtract 144 from both sides. Right, 144 minus 144. Go ahead and solve that. What is 324 minus 144? Okay, good. It's 180. So I should have drawn a line down the equal sign real quick. Okay, so now I have 12 times x equals 180. So you do the next step, which is divide by 12, because you're multiplying 12 times x. You do the inverse. So 12x divided by 12 is x. If you do it one side, you have to do it to the other side. So what is 180 divided by? Yep, your answer is 15. So this little piece is 15. So let's go ahead and check this. Let's see if the theorem is 12. 12 plus 15 is 27, right? 20, yes, 12 times 15 is 27. So let's try it. What's 27 times 12? See if it equals, it should equal the same thing as 18 times 18, which is 324. So try it. What's 27 times 12? Yeah, this is so cool. I just did it and it's 324. So see that? This is always going to be true. The whole thing times the piece sticking out equals the whole thing times the piece sticking out. Isn't that cool? It's a cool theorem. All right, let's try number 8. All right, here we have two secants, because secants hit twice and they go outside the circle. So see how they hit twice? They hit the circle twice, they intercept the circle twice, and they go outside the circle. So these two secants intersect right here. So I need to find the whole length of the top one. So the whole length of the top one is x plus 9. So x plus 9 is the whole entire length. Now I need to find the length of the piece sticking out. So the piece sticking out, I'm just going to highlight it, is this. So it's just 9. So the whole thing times the piece sticking out. So x plus 9 times 9. So let me write that. X plus 9. X plus 9. The whole thing times the piece sticking out. That's our theorem, right? Equals the same thing over here. The whole length. So this piece is 10. So 10 plus 8 is 18. So it's 18 times the piece sticking out. So how big is the piece that's sticking out? Well, let's check. I'm going to highlight it. The piece sticking out of the bottom is 8 units long. So times 8. So figure this out. What's 18 times 8, right? And then you have to do the distributive property here. 9 times 8x is 9x. Make sure you're writing this down on your notes. And then 9 times 9 is 81. So 9x plus 81 equals, figure out what 18 times 8 is. Okay, so we're going to draw a line down the middle. We're going to solve this. Here's my x. 9 times x plus 81. I have to get x by itself. It's being multiplied by 9, so they're stuck together. So that's the last thing I do is get rid of the 9. So I'm going to subtract 81 because I'm adding 81. So minus 81 on both sides. Subtract 81 here. So I'm left with 9x equals, what's 144 minus 81? Good, 63. So then the last step is to divide by 9 because I'm multiplying by 9. So I do the inverse. 9x divided by 9 is just x. But what I do on one side, you have to do it to the other side. So divide 63 by 9. And you should get 7. So let's check to see if it works here. So 7 plus 9. So what's 7 plus 9? 7 plus 9 is 16. So what's 16 times 9? Because if this is 7, 7 plus 9 is 16. So the whole thing, 16 times 9, yep, it would be 144. 16 times 9 is 144. Awesome. This always works. This is so cool. Let's try another one, number 9. Wait, before we go on, if you have any questions, let me know. We're on Zoom right now during your class time. Okay, let's do number 9. So the whole thing here, so the whole thing, 9 plus 11, right? Add that up. What's 9 plus 11? Then times the piece sticking out. So the piece sticking out would be this piece here, 9. Okay, for the top part, you should have read 20 because 9 plus 11 is 20 times the piece sticking out is 9. Now the bottom part, this part's the tricky part, but you just add them, 10 plus x. You don't know what that is, so we're just going to write 10 plus x. So just like that, 10 plus x times the piece sticking out. So the piece sticking out of this one, and I can highlight it for you right here, and you can also highlight it as 10. That's how much is sticking out. So 10 out of the circle. All right, go ahead and write this down on paper and then solve it just like the other ones we just did. Use distributive property. Okay, so 20 times 9, great, it's 180. And then multiply here, 10 times 10, and then 10 times x. Good, 10 times 10 is 100, 10 times x is 10x. Now I draw the line down the middle, right, and the equal sign. I want to solve for x, so the 10 is multiplying the x, and then I have 100 here. I'm adding it. So I'm going to get rid of the 100 first because the 10 is stuck to the x. So I get rid of the 100. So it's an addition. It's a positive 100, so I'm going to minus 100. 100 minus 100 gives me nothing, right? So all that's left on this side is 10x. But what I do on one side, I must do it to the other side of the equation because there we go. So 180 minus 100 is 80. So now the last step would be to, great, yeah, you're multiplying, so you can do the inverse. Divide, you always do the opposite operation. So 10x divided by 10 is just x. And I divide on this side, 80 divided by 10 is, great. You should have gotten 8. Very good. So this is 8. Then 10 plus 8 is 18. So 18 times 10 is 180. Yep, and it's the same thing. 20 times 9 is 180, and 18 times 10 is 180, so the theorem works out. The whole thing times whatever's sticking out has to equal the whole thing times the length of the piece that's outside the circle. Perfect. Good job. We'll do the next ones on your own. Please let me know if you don't understand this. I can help you. Okay, try this one, right? The whole thing is 8, right? And the piece sticking out, so hide the piece sticking out, is also 8. So these are kind of easier because the same number. And then the whole thing on the bottom, right, is x plus 6. X plus 6. And of that x plus 6, how much is sticking out of the circle? So let's highlight it. Yeah, it's 6. Right, so 6. So you're going to multiply by the piece sticking out is 6. So use distributive property. 6 times x is 6x. And then 6 times 6 is 36. And 8 times 8 is, good, 64. Go ahead and solve that. So I subtract 36, I have 28 equals 6x, divide by 6. And what should be your final? Okay, 28 divided by 6 is 4.666 repeating, so we round it to 4.7. Good, okay, we'll do number 11. Let me know if you need any help, please. Okay, try number 11 on your own. Okay, great, you should have gotten 16. Awesome. Let's try number 12. Okay, try number 14 and 15, please. Work on number 14. Okay, so for number 14, this whole thing is x plus 8, and the piece sticking out is 8. So you write that thing, x plus 8. The piece sticking out is 8. So I wrote x plus 8, because that's the whole thing, times the piece sticking out is 8. This part up here is the whole thing is 12, but also the piece sticking out is also 12. So I wrote 12 times 12. Then don't forget to use the distributive property. So go ahead and finish this one out. Okay, you should have gotten 10. Great. You multiplied 8 times x, 8x. 8 times 8 is 64. Subtract 64 from both sides. You have 8x equals 80. Divide by 8, and you get 10. Awesome. Try number 15. We're almost done. Okay, there's a hint on the setup. Right, the whole thing is x plus 9 times the piece sticking out is 9. The whole thing here is 15 times 15. Solve that one. Okay, you should have gotten 16 for number 15. Very good. Okay, we're going to review what we just did earlier. Let's just do number 16 and call it a day. Okay, we won't do the other ones. Number 16. So remember, if they meet on the inside, just highlight. Right, just highlight one section, right? Just highlight one chord. So it's piece times piece equals piece times piece because there's nothing sticking out. So it's just piece times piece. So x times 6 equals 3 times 4. Go ahead and do that one. Look back at your notes if you need to. Here's a little hint if you're stuck. X times 6, so piece times piece equals the other piece, 3 times 4. Last step, divide by 6. So your answer should have been 2. So 2 times 6 is 12, and then 3 times 4 is 12, so it works out. Very good. So I'm going to show you number 16, 17, and 18, but you don't have to do it. They're extra credit. If you just send me the answers as a just an email, I'll give you 5 points. There's number 17. You got to do both of them, 17 and 18. There's 17. Here's number 18. And go ahead and include 19 and 20 for the extra. It'll be extra 10 points if you do all those 4. Okay, that's it. Have a good day and work on your makeup work, okay? This is the last grade for this 9 weeks. So when you're done with this grade, I'll upload it, and that's it for this 9 weeks. We're still going to do assignments, but they'll be for next 9 weeks. So this is the last grade for this 9 weeks. Grades are due Thursday. So look at your grades. Everything's updated. I updated it last night. Thanks. Bye. Have a good day. Okay, guys? Let me know if you need anything with math or anything at all. Okay? Bye.